Hi everyone, this is Jiaming and Chunxu from Alluxio. Today we want to talk about some experiments that we have done about running Presto on ARM machines. First of all, let me give you folks a very quick introduction of Jiaming and I. Both Jiaming and I are working at Alluxio, and we are both working on some development work about Presto, and we have both contributed to the Presto DB community. So here, let me introduce Jiaming to talk a bit more about the major concepts of ARM machines and the major differences between ARM and x86.
In recent years, ARM has been quietly making its move slowly but steadily merging as a formidable competitor. Let's take a closer look at the numbers in the picture. In 2020, Intel's market shares of the server CPU stood at commanding 6.6%, with AMD holding 10.1%. ARM, known for its emergent efficient design, account for a modest 2.6% of the market, while others held a 0.7% share. Fast forward to 2023, and we witnessed a changing landscape. Intel's market share has steadily declined from 18.6% to 17.9%, while AMD has made significant gains, rising from 10.1% to 20.5%. However, the most remarkable shift comes from ARM, whose market share has grown from 2.6% to 8.1%, a significant increase. This number paints a compelling picture of ARM's slow but steady emergence in the industry, while x86 represented by Intel and AMD continue to hold considerable portions of the market. ARM's rise cannot be ignored. Its efficient architectures, combined with its growing performance capabilities, has captured the attention of business and customers alike. Next page, please. ARM and x86 are two different architectures used in computer processors. ARM uses reduced instruction set computing architectures. It executes a single instruction per cycle, focusing on software optimizations for performance. ARM requires fewer registers but relies more on memory. It features pipeline instructions and faster executions, reducing processing time. Compression adjusting is measured by software, and the compiler plays a key role in operations. Multiple instructions are generated from complex ones and executed individually. Managing code expansions can be challenging. ARM is commonly deployed in a mobile device where size, power consumption, and speed are crucial. On the other hand, x86 processors use complex instruction set computing architecture. They execute complex instructions, which may take more than one cycle. x86 focus on hardware optimization for performance. It uses more registers and less memory compared to ARM. The pipeline in x86 is less advanced. Execution time tends to be longer, x86 is inherently designed to handle complex addresses and use microprogramming. The architecture can manage complex statement executions at a time. Code expansion is easily managed, and decoding is handled in a complex way. x86 processors are commonly deployed in servers, desktop, and laptop, where high performance and stability are important. Next page, please. ARM processors offer several advantages: low cost, low power consumption, high speed performance, multiple processing capability, improved battery life, low store architecture, simplified circuit design. But there are also some disadvantages to consider. The first one is incompatibility with x86 architecture, making it incompatibility with Windows. The second one, certain processors may have speed limitations. The third one, instruction scheduling can be challenging. And the last one, programmers may face greater challenge when developing for ARM processors. Next page, please. ARM currently boasts a rich and diverse ecosystem in various areas, including operating systems, cloud computing, containerization, visualization, networking, big data, AI, and database. The richness of ARM's ecosystem in this domain is a testament to its versatility and adaptability across a wide range of technologies. ARM's architectures, coupled with the efforts of software developers, industry collaborations, and open source communities, has fostered an environment where ARM-based solutions thrive in operating systems, cloud computing, containerization, visualization, networking, big data, AI, and database applications. Let me introduce Chunxu to talk about the experimental results.
Thank you, Jiaming. Here I want to talk a bit more about the experiments that we have done about Presto on ARM machines and x86 machines. So here is some configurations that we have implemented for the experiments. For the Presto cluster, we deployed one coordinator node and 4 worker nodes. And for the instances, we use different type of machines for ARMs and x86. For ARM, we use the machine R6G, and for x86, we use R5 and R6A machines. And we'll talk a bit more about them in the next slide. And for the operating system, all the machines hosted CentOS 7 as the operating system. And for the software, we use like Presto deployed with Alluxio as a local cache, and we also deploy Hadoop and Hive for the experiment. And for the instances here, we use 3 different types of instances for the experiments. For the ARM machine, as we mentioned, we use R6G, which has 16 CPU cores and 128 gigabytes of memory. And for x86, we use 2 different types of instances. One is R5 and the other is R6A. And both of them have 16 CPU cores and 128 gigabytes of memory. So we can see that all the instances share the same hardware resources. But the cost of these instances are not the same. From our observation and calculation, we find that ARM machines have the lowest cost compared with x86 machines here. And for the x86 machines, we could see that R6A has a bit lower cost than R5. On this slide, we want to talk about the concrete results collected from the experiment. We ran the Presto against the TPCDS benchmark. We ran the full benchmark here, but due to the space limitation, we just showed the results of the query 10 to query 20. So the figure on the right is about the query execution time. So the shorter, the better. The blue bars are from the machine x86R5, and the red bars are from the machine x86R6A, and yellow bars are from the machine ARM R6G. So first, let's compare the x86 machines. From what we could observe, that the red bars are always shorter than the blue bars. So we could see that we suggest R6A machines over R5, as R6A has higher performance and lower cost. And for the ARM machines, those are the yellow bars. We could see that the yellow bars are always shorter than the blue bars, but they are a bit higher than the red bars. For some queries, yellow bars are pretty similar to red bars, and for some queries, yellow bars are a bit longer, higher. So in summary, we find that ARM machines have lower cost with comparable or even higher performance than x86 machines. And if we compare all the bars here, we could see that of all the 3 types of machines that we have ran Presto against the TPCS benchmark, the x86 R6A instances, who has the yellow bars, achieved the highest performance. So that's generally what we have collected from the experiments. And thank you.